Welcome to Methamphetamine. Today we're gonna do the integral of x squared minus 1 over ln(x) going from 0 to 1, and then integral of x squared minus x over ln(x) going from 0 to 1. And this is a really unpopular one. And I just randomly think this integral. Just put the integral of this in Wolfram alpha. It actually converges going from 0 to 1. And this integral is really famous, but both of them, they need to use the Feynman technique in this point because they are not elementary. Just these two one cannot be integrated in elementary way if this indefinite integral. So over the first one is really famous. So let our I of a. I like to use a as our variable if we use the Feynman technique. I of a is equal to the integral 0 to 1 and then ln(x) dx. And this is just x power of something. I'm going to put down a to here like that, because if we differentiate both sides in the a row and the x is just a constant, so for differentiate x power of a, you get x power of a times ln(x). So that's ln(x), and this ln(x), they will cancel each other out. So you get I prime of a is equal to ln(x), right? And then you get x power of a times ln(x), because ln(x), 1 over ln(x) is just a constant in the a rows. They're the same. So far, just get that x power of a times ln(x) over ln(x), and then this ln(x) and this ln(x), they cancel each other out, and then integrate x power of a going from 0 to 1 is what? Just add 1 to the power divided by the new power, you get x power of a plus 1, and then multiply by a plus 1 going from 0 to 1. So far, be sure you need to put a 1 and 0 into the x another a. I make this mistake many times. So over, if we put 1 power of anything is just 1. So far you get 1 over a plus 1 times 1 is just this 1 over a plus 1, and then subtract this. So over 0 power of anything is just 0 to 0. So over, we consider a is greater than 0. Both of them are greater than 0. So I'm going to use a Feynman technique in this as well. So that a need to be greater or equal to 0 as well. It will be converges. And we don't want a smaller than 0. Always don't want a smaller than 0 because this function will be diverges. So over, you get 1 over a plus 1 minus that 0 is just 0. So over, I prime of a is 0 to this, and then we're gonna integrate both sides. You get I of a, and then integrate this, you get ln of a plus 1. But don't forget to plus c here. So we're gonna figure out what's the constant here. Just choose. I don't like to write so many steps here, so choose a is 0 to 0. So far, I of 0 is just equal to 1 from 0 to 1, and then x power of 0 is what? 1 minus 1 over ln(x). So for 0 over ln(x), you get 0. Integrate 0 from 0 to 1. Since 0, it doesn't have any area, you just get 0. So far, we figure out what's our constant here. So over, put a 0 into it. ln of 0 plus 1 plus c is equal to that 0, because I of a, they equal to each other, right? Each other. So far, ln of 0 plus 1 is ln1 is equal to 0. So far, you get c is equal to 0, right? So over, I of a is equal to ln of a plus 1, like that. So far, this original, just put these two, right? A is equal to 2 compared to each other. So far, this is equal to I of 2. I'm going to just skip the step. I of 2 is equal to ln of 2 plus 1 is just 3, like that. ln 3. And this is really amazing. So the integral is equal to ln phi. You can choose any number into a that's greater than 1, greater or equal to 0, and you can get the general formula is equal to ln of a plus 1. Do it yourself. And I think this is the easiest integral to use the Feynman technique, right? This is really famous result, really famous integral to use the Feynman technique. That integral, but this one I don't think this is popular. Just I randomly figure how to do this. Just randomly put down this integral going from 0 to 1 into root from alpha is actually have the general solution. So going from 0 to 1, I'm going to put down a into s as well. So for x over ln x. So over I of a is equal to the integral of x power of a. Since x is a constant, multiply by ln x once again, divided by ln x. And then be sure negative x is a constant in our a row. So far you just get 0 to here plus 0. So this you pretty much just do the same as well. So let me just do this really quick. Just ln of a plus 1 once again. So the differentiable side get I of a is equal to no, not ln of a plus. I'm going to write this as 1 over a plus 1 first, and the integrable side get ln of a plus 1 plus c. However though, c is not always gonna be equal to 0. So this time that c will be different. Because this is not 1 anymore. This is x. And this is totally different. Be sure a is greater or equal to 0. And sometimes a is just greater than 0. If we use the Feynman technique. So over. Let me just show you the step. Still show you some step. Ln dx. Plus a, put a is equal, use the equal sign. A is equal to, how can we do this? If we choose 0, but no, this time is different, really different. A should be greater than 0 in this point. Because if a is equal to 0, x power of 0 is just equal to 1. 1 minus x over ln x. It will be divergence. Be sure. But is this divergence? Let me check. No, it's convergence. Actually convergence, because this just we already do x power of a minus 1 over ln x. A should be greater than or equal to 0, and that's okay. Just switch the order. Just the order that switch. So a is equal to 0, that's okay. So far, just a is equal to 1 here, because x power of 1 is just x minus x is just 0 divided by ln x. So far, you get ln 2 plus c is equal to 0. So far, c is equal to negative ln 2. That's really nice. So far, you can get this I of a. Be sure you need to show the entire step if you do it. If your teacher asks you to use Feynman technique, you need to show you some steps. This is a teaching video, so I'm going to just give a lot of steps and erase them. And then ln of a plus 1 minus ln 2, you can combine the logarithm. You get ln of a plus 1 over 2. So far, this original is just x squared minus x over ln x. Compared to each other, you can get a is equal to 2. So far, you get ln of 2 plus 1 over 2 is 3 over 2, ln 3 over 2, and this is really cool. Of course, you can choose a as any variable. This is the general formula to find, right? the integral of x power of a minus x over ln x going from 0 to 1 if a is greater or equal to 0, like that.